Welcome on the second part of webinar in relation to STAG Diesel issue.
That's right. We mentioned in before webinar how diesel engine works, how to choose the proper STAG Diesel set according to the sensors, according to the type of the engine. And right now, as you can see, we have our diesel engine Honda Accord.
Yeah, so it's a 2.2 CDTI
right.
diesel engine, and now we can show you some components installed on the engine. So the first and of course one of the most important thing is the gas rail, and as you can see on the engine it's a common rail diesel, and we have let's call it like a common rail gas, because all four injectors are connected together to one rail, and then using the pipe the output is connected to the intercooler connection. Then we cannot see it because it's low down and it's not possible to show you here. Mm-hmm. Then we can see the diesel rail, yes, and on the end of the diesel rail there is a pressure sensor, and then the pressure sensor is electrically connected to the STAG Diesel. What we can show you on here, there's more components, like we have the gas filter. Mm-hmm. And the gas filter output is connected to the injectors, of course, and to the reducer. The next components what we can show you from this position is only the socket of the NOx sensor. Mm-hmm. The EGT sensor and the lambda sensor is above the car, because on the output of the exhaust pipe there is not possible, it's under the car, so we can show you just other situation when the car goes up, yes, and later we will show you.
That's right, that's right. So about the sensors, right?
Okay, how it looks like the EGT sensor, yes. EGT sensor, the output of the sensor, there is a sleeve. Later we will show you on the situation when the car will be upped. And the next component, it is Sonda. It's a lambda sensor.
Mm-hmm. Wideband oxygen.
Yes, wideband lambda sensor. And lambda sensor is installed in the sleeve. And this sleeve should be welded in the exhaust pipe. I will show you the sleeve. It looks like this. Yes, and the lambda sensor is screwed in. And you can find also the silicone substances on the thread, and these substances is with also chemical components to prevent the corrosion after some millage, that you can easily remove the lambda sensor from the exhaust pipe. And last thing is...
And the last thing is the NOx sensor. So here you have the NOx sensor. The only thing that you can see when you are looking at the car is just only this green connector. Here you can find that green connector, and the main part of the NOx sensor is screwed to the block of the engine. It should be screwed to the block of the engine in the middle of the engine. So that's why we cannot see it right now, right? So
exactly. And don't forget mm-hmm. about the main rule. And the main rule is to mount it as close as possible to the connection, the engine block with the head, and also in the geometric middle of the distance of the engine block. This is crucial to read properly the knocking signals from each cylinder.
Right. If there is a rust, you should clean up the surface to get exactly. the proper connection. And very important thing is the torque that you are using.
Tightening torque.
Tightening torque that you are using to connect this sensor to the block of the engine. It's 20 Newton meters, and you need to be careful.
Yes,
when
be
you
aware
are
on this. Yes, because it's crucial.
It's crucial. That's right.
Okay, so the next stage we will rise up the car, mm-hmm. and we will show you the lambda sensor and the EGT sensor. So now we are under the car. We are able to show you the two sensors, the lambda sensor and the EGT temperature sensor.
That's right. Here you have the part of the exhaust, yes, the exhaust pipe of this car. And as you can see, there are two sensors that we mentioned a few minutes ago about them. Here you have the EGT sensor. so exhaust gas temperature sensor, and the lambda probe that is measuring the amount of the oxygen in the exhaust, right?
Yes, and the most important thing in relation to the position of the lambda sensor is the angle from this horizontal position of the exhaust pipe. So if we took this line as a horizontal, so we should install it more than 15 degrees from this position. There will guarantee the proper readings, and of course it will extend the life of the sensor, because if you want it like this or the position like that, it can occur that there will be a high humidity on the end of the sensor, and it will just block the flow, and then also it will damage the sensor. So don't forget, do it more than 15 degrees from the horizontal position. And of course, as possible, we should mount close to the exhaust manifold. The same relation about EGT.
Right, the same relation about the EGT. The distance between the engine, the block of the engine, is very important, because if there is no possibility to install in this part of the exhaust both sensors, EGT or lambda probe, and you must install it far away from the block of the engine, you need to take this situation when you are trying to adjust the system, because as far away from the
you need to add
block
a threshold for the maximum temperature.
That's right.
In this construction, the position of the sensor is just around 30 or 40 centimeters from the exhaust valves. But in situation when from the construction side there will be no pipe like this, and you need to find a different position, you need to add the threshold every 50 centimeters, you need to add every 50 degrees or even 70 for the safety reason. So the same in relation to the temperature. Of course, the lambda position, there is no exact influence on it, but the temperature is very crucial thing.
Yes, when we'll be once again above the car, so and we are trying to explain how our software working, you will see also the parameters where we can put exact temperature of the EGT sensor.
So let's back to over the car,
right,
and we'll follow the rules in the application.
Right.
So follow the next steps. We are now want to show you the base settings of the application in the STAG Diesel. AC STAG application is the same application as we are using to configure the STAG QMAX, QBox, and the family of the Q products. And we ask now to show the screen. Okay, and the base settings, you have the engine parameters, and the first field is related with the number of the injectors. So even you see here cylinders, it's not related with the number of cylinders of the engine, it's the base relation to the power of the engine, and Thomas explained you in the webinar, in the previous webinar in relation of the base settings. Then we have engine type, the mechanical, unit injectors, and the common rail, so you choose proper which one engine it is. And the source of the RPM, we have the camshaft, crankshaft, and of course if the engine is a mechanical and there is no existing, so we need to add the source or use existing. For an example, old mechanical engines, we can find the alternator, and on the alternator there is an electronic unit control the voltage, and sometimes there is a pin that we can experimentally connect the brown wire and see the effect of the readings here on this area. And if it's unstable, so we have two another areas. One is related to the revisions, so if the RPMs are too high, so we can change the multiplier. And also if it is unstable or unreadable, try to find out the voltage threshold from 0 to 12 volts, you can arrange it. Again, if still RPM readings are unstable, you can use the RPM filter. Just turn it on and see the reaction of the readings should be stabilized. Injector type. During auto calibration, if you set auto calibration on, if injector is connected, then ECU will automatically recognize which kind of injector it is. It's inductive or reverse inductive or piezoelectric. It should be shown after auto calibration. You should see the diesel injection dose should be on idle, that you can see some values. This value, it's not like a typical on petrol that you can see 1. Sometimes you can see 4, 5, or even 10. It's no matter. There is not such a big deal if you can see even 100 here.
The important is reading, stable readings.
It should be just a stable reading. If it's up here, it's okay, no matter the value. Value can be 5, 10, 100, it's no matter. Then we should go to the gas control settings, and as you see, this is a typical area when we are choosing the parameters like in Qbox and Qmax settings, and so Thomas will talk about these two fields.
Areas, right. So the main settings are pretty the same like in the Q generation or 400 dpi, but here in the calibration parameters you have new parameter that is not available on the Q platform. It's cut-off threshold in voltage. The cut-off threshold, just like in calibration parameters, is set automatically after the calibration. If you have the TPS connected on the monitor window, you have acceleration position pedal, some value, depends of the engine. So after the auto calibration, our system set this value automatically. It's the value 0.1 voltage lower than we have on idle. You can use this parameter, the cutoff threshold, when you are adjusting the system, and if you don't want to get the injection of the gas during the cutoff, so when the engine is braking, during the engine brake, when you are not using the acceleration pedal, then you have to set this cutoff threshold. Okay, in this situation, our controller will not inject gas during the cutoff. On the right side, you have to switch over to diesel parameters. Minimum, maximum RPM, intermediate phase, pressure, error, delay are the same settings. We have the same settings like in the Q generation, or when you're talking about intermediate phase, it's just like in 400 dpi. But here you have the maximum exhaust gas temperature and maximum NOx combustion, right? So these are new parameters that we were with Marcin explained you before in the previous webinar. Very important values according from the one side with the adjustment of the system, setting of the system, but on the other side with the safety of the engine. So the maximum exhaust gas temperature is the value read from the EGT sensor that is mounted in the exhaust. We presented connection a few minutes ago under the car, and the max NOx sensor is the readings from the sensor that is on the block of the engine. You have two options that you can use those two values. I mean, max exhaust gas temperature set automatically by the system, and the same with the NOx sensor that you can also set automatically by the system. If those fields are not marked, that means you need to manually set maximum value of the temperature and the maximum value of the NOx sensor. If you mark one or the second field, that means that system, when you are driving on the diesel, system will automatically set maximum value that is read from the EGT sensor or from the NOx sensor. Okay, so you can use automatically settings or manually set maximum values.
And don't forget that the automatic settings, it's occurring, the efficiency is going a little bit lower than on manual, because doing the automatic settings, the system is having a little bit bigger margins of these values to prevent some issues on engine, yes, in relation to the temperature and the knocking level. So if you want to go with the better efficiency on diesel dosage, you should set it manually. So you need to compare the maximum temperature of a diesel during drive on diesel on hard conditions of the load. Remember it at some value, because on the diesel engine, like the exhaust gases can reach during DPF burning cleaning procedure, the temperature can rise even 700 degrees. But without this, normal operation temperature is like 400 or 500, and also depends on the position of the sensor that we talk about during under the car position. In the same situation with the knock level, you should compare it to the diesel at 0.5 or 0.3, depends on the position of the sensor, depends on the construction of the engine, how big is the engine, mean the capacity of the engine, the single cylinder capacity, so we can add more than 0.2 or 0.5 threshold comparing to diesel knocking level.
Right, and the safety aspects of those two options, according to the STAG Diesel, are that when our system get the readings from EGT sensor, for example, and the value is higher than on diesel, STAG Diesel is changing to the diesel, stop to injecting gas, waiting until the temperature drop down by the around 50 degrees, and then return to the start injecting gas once again. The same situation, not the same, but similar situation we have on the knock sensor. If our controller detect knocking higher than on diesel, change to the higher than on diesel, change to the diesel, stop injecting gas, okay?
And occur an error, yes.
That's right,
it
and
will not
represent error.
Yes, and will not back automatically to supply the gas dosage.
Sensors and actuators, we have two new sensors. Lambda sensor type is factory or from the kit. That means you can connect STAG Diesel to the lambda probe that is in the car, but we recommend to use our lambda probe because it's better not to connect to the factory, because we can have distortions in the readings when the car is working on diesel. And the knock sensor, as we will talked about on the previous meeting, or yes, I think in the previous webinar, we talked that we can connect two knock sensors.
Yes.
Right. And the last thing.
Yes, and the last thing in the settings is the window with advanced settings when we have a map type. So there is a manifold pressure, and there is a diesel injection dose, and this is a place when we choose the type of regulation of the gas dosage map. And we are sure that from the many tests that the manifold pressure is the one of the best for efficiency map. Diesel reduction, you can active or inactive if you are connected to the pressure sensor of the common rail engine. And you have both emulator settings, depends on which connection is made, either fuel pressure or acceleration pedal. Then adaptation mode, you have manual, semi-automatic and automatic. And in both modes, automatic and semi-automatic, the efficiency is with the big margins of safety, and if we have high safety, we have low efficiency. So if you want to have better efficiency, set it manually. Injection type is a kind of way of spraying the sequence of standard altogether injectors they are working during system, and leaning threshold depends of the reaction on the throttle. If you press the throttle suddenly and you see some effects with the black smoke from the pipe, exhaust pipe, or some jerks, so you can reduce or you can rise up this threshold and experimentally to just fix the issue with this smoking problem. and the gas dosage change is the result of changing the gas dosage on the map. So if we go from the 0 milliseconds to 10 milliseconds, so if you choose very slow, it will influence on the timings how much from it will go from 0 to 10. Yes,
the speed.
It's 0. It's just the speed of the change of the gas dosage.
That's right.
And because of this crucial thing of the gas dosage map settings, it's a very sensitive topic. So we will record for you a special I think from live stream from driving situation on the road. Today's conditions are very tough in Poland. Now we have around 70 centimeters on the road, so even walking is very hard to do this. So we are not talking about driving and regulating the diesel from the training purpose. Yes, so
right.
We will produce it for you to the next stage. We are sure.
I think so.
At this moment, I'm sure that we talk about enough about the settings. The next stage will be more related to more practical skills with the driving. Yes,
that's right.
For sure, it's needed to be done on the next webinar. So today, guys, we are want to have some comments from you, some questions. As soon as possible, we will answer the questions using, so please just make some comments on the movie, or just write an email, or use the Facebook profile. In email address is stag@stag.pl. Of course, you know the profile of the Facebook because it's related on with this movie, so easily you can find it. Thank you for your time and see you on the next webinar.
That's right. We are waiting for your feedback, any comments. Stay tuned.
Bye-bye.